Okay, triangle ZAB is inscribed in circle O and segment ZB is a diameter of circle O. Given that triangle ZAB is inscribed in circle O and segment ZB is a diameter, Abigail must try to prove to show that angle ZAB is a right angle. Which theorems or statements should Abigail plan to use in her proof? There is more than one correct answer choice. So the first thing that I'd be looking for is an example proof to show that the angle is a right angle. So right here I'm noticing that this angle is a right angle. It looks fairly similar. There's one part that they have drawn in a radius, which is not duplicated anywhere else. So we're just going to go back up and check this one out. I think I went too far. Okay, here we go. I'm noticing that I'm just picking out, we have that there's a semicircle. We know that then the angle is 180 degrees. Then by the inscribed angle theorem, by the substitution property of equality, and then simplifying, and definition of right angle. And I'm looking at this and I'm not seeing a single one. So the next thing that I would go through is I would start looking for this list of postulates and theorems, and I would just scan for the vertical angles theorem or the base angles theorem, and I'm right here. If the base angles of a triangle are congruent, then the sides opposite those angles are congruent. So I'm just jumping here. I'm noticing that this angle is x and this angle is x, so that means that this side, because it's opposite that x, and opposite this side opposite this angle x, would be congruent. And we also are noticing that this is y and this is y, so that means this side, which is already marked, has to be congruent to this side, which is already marked. So right now, base angles theorem is where we're headed. And then noticing that ZO and OA and OB, those are radii, so all radii of the same circle are congruent. That is what we would use, because then if we know that, then we know that since y is opposite a radius, it has to, angle y is opposite a radius length, and angle x is opposite a radius length. That also has to, that means that they have to be equal to each other. So then these two would have to be equal to each other, and you could set that up to divide it by 180 degrees since that's a diameter. So those are the two theorems that we would use.